So the first thing we should talk about is homework. Your first homework will be posted today and due next week on Tuesday at 11:59 p.m. That's Tuesday the 14th. I'll have it up by midnight tonight. I have it ready, but I might add a few questions to it. Okay, Canvas today. So just a reminder, your homework will have multiple choice options. You have unlimited attempts, no time limit, and you can ask questions about your homework anytime, even during class. Okay. So we want to go over graphing inequalities. Oh, raised hand. Yep. Any questions?
Yes, so yesterday I was going through the recordings. I don't know if it was just on my end, but the second video didn't have an audio from
Okay.
Thursday's lecture.
Okay, I'll check that. I think I can make sure that the video converts on my laptop and I'll reload it and see if that will work. But thank you for letting me know.
Thank you.
Thank you too. Let's see. I'm going to try this live transcript and I'll try to pronounce or enunciate and make sure that it hears me, but let's see how this goes. Enable audio. Let's try this. Hello. Cool. Graphing inequalities. We will start with a number line. So going smaller and smaller towards negative infinity, this way towards positive. Use an open circle for strict inequalities. Use a closed circle for greater than or less than or equal to and greater than or equal to. Plot values of your inequality on that number line. And I'm going to talk about using test points. So this is going to split the number line into places to pick a point to test. And then if the test is true, we shade that area. If it's false, we don't shade that area. And I'll do a lot of examples. Okay, so use test points that are between the plotted points, the ones that were in your inequality. And those points that you put on your number line, they're going to have those closed circles or open circles. So between those marks, we're going to have test points. So if it's true, shade over the test point. If it's false, do not shade over the test point. Now we do examples until probably the end of class, but maybe we'll reach a new topic. We'll see. All right, first example. There we go. Okay. Graph the set that's going to contain all x in R, the real numbers. So this double bar R is all real numbers. We've started a set. This is our variable. It's some real number such that x is greater than or equal to 3. And then there's another curly bracket to close the set. Okay, so we're going to plot the number 3, and then we're going to put test points below that number and above that number. So underline. I need 3 on this graph. So the first test interval goes from -infinity up to 3. And let's go ahead and use the right symbol here. It's going to be a solid dot. And then from 3 to infinity is the other test interval. So it starts, in a sense, from -infinity, and you don't include -infinity. So it's parentheses, -infinity over to 3. And for the test interval, we're just testing up to 3. You can include 3 or not. We'll see. We're not including 3. we know that that's a true value. So let's go below 3 and above 3. So from here to here. So any number less than 3, we're going to test. Let's try 1. So you're putting 1, this x is 1 is a real number, yes. And is 1 greater than or equal to 3? Nope. That's false. So just make sure you put your test points in whatever the instructions are from your set. Okay, so we're not on this side. Let's try that side. Test some number greater than 3. Let's just do 4. So we're testing this interval over here, see if we want to shade over it or not. Okay, so back to your set, which I have in my notes. We're putting 4, and is it greater than or equal to 3? 4 equal to x. Yes. 4 is greater than 3. It keeps going, so just put an arrow on. Okay, there's more to this question that I should have asked at the beginning, or I meant to put in the instructions. So write the set in interval notation. Okay, so remember, you start with a small number on the left side. This starts at 3. It goes over to positive infinity. Include 3 with a square bracket, but positive infinity is always going to have parentheses on it. So going to start at 3 and include 3. Go over to infinity. All right, so this here means the same thing as the set that we wrote at the beginning of the problem. It's all real numbers x that are greater than or equal to 3. This time we're doing a similar but different set. Graph the set of all x and r. The real numbers are x is less than 3. We will write the set in interval notation. Starting the graph, we're going to place 3 on the graph. And check out your inequality. There's no equal sign. It's a strict inequality. So there's an open circle. So the test intervals are similar. You're testing from -infinity over to 3. And I want to say these are very detailed notes. Some of you may have seen this in a previous class and may be able to draw a graph quickly, but others maybe have seen this for the first time, or it's been a long time. So we're talking about different ways to solve a problem. This is one way. Also test from 3 over to infinity. So you just need one test point in each interval. I'll just try x equals 2 for the first interval over here. In this interval, let's go with x equals 5. Okay, first one, x equals 2. So check out the set. What is the instructions? It's going to have 2 less than 3. 2 is less than 3, so that's a true statement. When you have a true test point, shade over that point. And we're just going to check that we don't want to shade the other side. So we're putting in x equal to 5. Back to the instructions in your set. Would 5 be less than 3? No, that would be false. So you do not shade that side. So that's the graph. And and the set in interval notation looks like. We're going from negative infinity, which negative infinity and positive infinity will have parentheses every time, over to 3, and do not include 3. So it also has the parentheses. All right, we just keep on doing examples kind of like this. Next one is going to be the set of all x and r that are less than or equal to 7. X in the real numbers such that just saving this for anyone taking notes. Start a number line. 7. The closed circle. So we split the number line right here into 2 intervals. We're going to test from negative infinity up to 7, and then from 7 and over to infinity. All right, so some number less than 7, just do x equals 6. And then I can test a number greater than 7. Let's try this a little bit further. Okay, putting in 6 to the set. 6 less than or equal to 7. 6 is less than 7, so this is true. So this is a true test point, and that makes this whole interval a solution section. Let's just make sure that we did shade the right side and test x equals 9. Put in 9 to the set. 9 is a real number. Cool. Is 9 less than or equal to 7? Nine is not less than 7, 9 is not equal to 7. This is false. So we do not shade over that test point. So all of that work was really just scratch work to get this graph right here. So again, like test intervals are scratch work, even putting in these little points, the test points was scratch work. To finish the problem, we need to write the set in interval notation. So from negative infinity over to 7. So let's check if anyone has questions. So this one's a little bit different, but we're going through the same questions. Graph and write the set in interval notation. It's going to be the set of X and R, the real numbers, such that 1 is less than X, which is less than 4. And then close the set. And write the set in interval notation. So let's put down a number line. We need to place 1 on the graph, and we also need 4 on the graph. So any values that you see in your inequality need to be on your graph. And also just a note, put your units as best as you can. Try to draw them equally spaced. So let's go like this, break this up, and then label it with for the number 1, we have an open circle. It's x is strictly greater than 1. So that's one part of this statement. The other part is to have x less than 4. So 4 also has an open circle. So those marks have split up your interval. You go from -infinity over to 1, between 1 and 4, and then from 4 up to infinity. This one. I'm going to go between 1 and 4. And from 4 over to infinity. So we need 3 test points. Let's use x equals 0. Here, we're not going to use 1. We're going to pick something between 1 and 4, like let's try 2. And then we'll put in x equals 5. So you need to put this into the information from the set. So is 1 less than 0 and is 0 less than 4? Okay. 0 less than 4 is true, but 1 less than 0 is false, which makes the whole statement false. So do not shade over x equals 0. This side here. Okay, so between 1 and 4, I've picked 2. Try x equal to 2 as a test point. Back to your set. We're putting this into the statement 1 less than 2 less than 4. So check through. The whole thing has to be true. It's a true statement. 1 less than 2, yes. 2 less than 4, yes. This is true. Okay, so that's a solution, and that makes this whole piece a solution section between 1 and 4. And we're just going to check that we don't want to shade over here. So we're going to put in x equal to 5 as a last test point. It's 1 less than 5, that less than 4. So the first part's okay. 1 is less than 5. However, 5 less than 4 is false. So the whole statement is false, and you do not shade over x equals 5. So there's the graph. And then write the set in interval notation. So your small number goes on the left side, larger number on the right side. You want to go from 1 and not include 1 over to 4 and don't include 4. Let's do this one. Graph the set. We're going to stick with the variable x. And it's a real number. Such that -1 is less than or equal to x, which is less than or equal to 2. Actually, let's just do strictly less than 2. And write the set in interval notation. So we're starting with a number line, and we need -1 on this number line. We also need to place 2 on it. Mark some units, try to have them evenly spaced out. Let's go from -1 somewhere to 0, 1, 2. Okay, -1. Looking at this part, -1 less than or equal to x. So -1 has a solid dot. The other part is x less than 2. So an open circle over 2. The test intervals go from -infinity to -1, between -1 and 2, and from 2 over between -1 and 2. And the last one goes from 2 to infinity. So I'm going to try testing x equals -2. I'm going to test, let's check x equal to 1, and x equal to, let's go with 4. Okay, first test. Set instructions say to have -1 and then put in your test point less than or equal to -2 and less than 2. So for this to be true, the whole statement needs to be true. -2 is less than 2, but -1 less than or equal to -2 is false. This part here gives us a false statement. So we're not going to shade that interval. Next point I picked is x equals 1. Putting that back into the instructions from the set. We have -1 less than or equal to 1. So let's check this. -1 is less than or equal to 1. And 1 is less than 2. So this is true. So we're going to shade over that test point. And over to the side, and over to that side. And we're going to check if we need to shade this part over here. I picked x equal to 4. So -1 less than or equal to 4, and is that less than 2? So the first part's okay. -1 is less than or equal to 4, but 4 less than 2 is false. So we're not shading over that section. So we do have the correct graph. Graph is good. And we're going to write that set in interval notation. So if you have a question on your homework or a test, and it just asks for interval notation, I think it's good scratch work to draw the graph. So we're writing the set as a set that includes -1 and goes over to 2, but does not include 2. And reminder, the square bracket means you include the number. That number is in the set. The parenthesis means you're going to get really, really close to 2, but never actually use that number 2. Just get like 1.9 and 1.9999 and like closer and closer to 2, but never actually have 2 in the set. Okay, let's go on to something like this. We're going to graph the set of X in R. Such that X is less than 4. Then there's a comma, or X is greater than or equal to 7. And then close the set. Okay, and write the set in interval notation. Squeeze this up here. Okay. So we're starting with a number line to do the graph. We need 4 on the graph and we need 7 on the graph. Let's put some units down. 4, 5, 6, 7. I'm going to test from -infinity over to 4. And in this part, the strict inequality means that there's an open circle. Let's make sure we plot that other point. So for that point 7, we have greater than or equal to, so there's a solid circle over 7. Solid dot. Okay, so those marks have split up the number line from -infinity to 4, between 4 and 7, and then from 7 over to infinity. So the statements we had before with the previous example, the whole statement had to be true in order to be true. Or if part of a statement was false, it made that whole phrase false. However, with or, as long as one of them is true, it's true. So if this one or that one is a true statement, then it is a solution. Like your test point will be a solution if it satisfies one of those things. Okay, let's try x equals 3. And I'm going to put in 8. I'm also going to test 5. Okay, is 3 less than 4, or is 3 greater than or equal to 7? Try this. 3 is less than 4. 3 is not greater than or equal to 7, but I just needed one of those pieces to be true. So that's a solution. This is a solution section over here. Up to 4 and over to negative infinity. We're going to test x equal to 5. Putting in 5 less than 4, or 5 greater than or equal to 7. Let's go here. It's 5 less than 4. Nope. Is 5 greater than or equal to 7? Neither of them were true. So this is false. So we're not going to shade over x equals 5. So this part here is blank. Let's go from here to here and try x equals 8. All right, so if we put in 8 to the instructions from the set, we have 8 less than 4, or 8 greater than or equal to 7. 8 less than 4 is false, but 8 is greater than or equal to 7. So this part's true. And with or, as long as one of those pieces is true, then that is a solution. And so you shade over that section. That your test point was in. So here. So what we'll do to put two sets together, this set or that set, is use the union symbol. So we union the two sets written in interval notation. So the first set again, like smallest number on the left side, which is negative infinity. It's not a number, it's just our lower bound. It has a parenthesis on it every time. Going from there over to 4 and do not include 4. Parenthesis. Union. With the set that goes from 7 and does include 7 with a square bracket and goes to positive infinity. And this is the solution set written in interval notation. Okay. I'm gonna do maybe 2 more examples and then I will be done with class. So this is another set with or in it. Going to graph the set. That is all x and r, the real numbers. Such that x is less than 8 or x is greater than or equal to 12. And write the set in interval notation. So this graph is going to need 8 on it and 12. And let's get started. Eight has a strict inequality, so there's an open circle over that. Let's move over, let's go like this. Get my units down, kind of space them out evenly. Let's plot that point with an open circle. And over 12, we need a closed circle. So we're testing from negative infinity to 8, between 8 and 12, and then from 12 to infinity. 12. Okay, let me just make a little note to myself. So we're also doing from 8 over to 12. And from 12 up to infinity. I'm going to test 7. And let's pick 10. And 13. Sometimes I forgot. Sometimes it helps to maybe like draw a little split, like just a scratch work, just a little like you're breaking this up from here to here and over to here. And then testing past that. All right, first test. Checking out the instructions. Is 7 less than 8? Or is 7 greater than or equal to 12? This one's true. 7's less than 8. And with or, as long as one piece is true, you have a true statement. So even though 7 is not greater than or equal to 12, this is going to be true, and we shade over x equals 7. Then we're going to test x equal to 10. So checking out the instructions, is 10 less than 8? Or is 10 greater than or equal to 12? Less than 8, it's false. 10 greater than or equal to 12. False. This is false. Do not shade over that point. Oh. I'll be right back. I have a cat emergency. Bye. Okay. Cats get bored and then they cry. Okay, but we have toys. Anyway, we are not shading over 10. Last test point is x equal to 13. Okay. 13 less than 8 is false, but 13 greater than or equal to 12 is true. So since this is true, and we have or, that statement is true, and we will shade over 13. So we're done with the graph. We've tested each test interval and shaded accordingly. And last thing we're going to do is write the set in interval notation. The set goes from negative infinity over to 8. You never include negative infinity. And this time we also are not going to include 8. So it has a parenthesis. Then we're going to union with the set that goes from 12 and includes 12 with a square bracket over to infinity. Okay. That'll be at the end of class. And again, I'll have your first homework up at some time today, hopefully this afternoon. And we're kind of done with going over graphing inequalities. So if you have questions about it, just let me know next class. Otherwise, we're going to move on to a different topic. Okay, thank you, everybody. Call this the end.